Good morning, everyone. So my name is Junel R. Macalisan from Technological University of the Philippines, and I'm one of the author of Drive Awake, Yellow version 2 machine vision interface interference approach of eye closure for drowsy driving detection. So, main road accidents have been one of the most alarming issues in society. So because of traffic accidents, about 1.25 million people around the world uh, died last year. And one of many causes of this is drowsiness of driving or owing to over fatigue or tiredness. So drowsy driving contributes to or increase the number of traffic accidents each year. There are also these are also alarming from Philippines, which report in Philippine Statistics Authority, wherein shows that from 2006 it reported that about 1,513 and then up to 10,379 last 2015. So factors such as reckless driving, overspeeding, drink driving, human error, and even drowsiness have been the leading cause of traffic accidents here in the Philippines. So as one of the researchers, so we are interested in reducing road accident by tackling the issue of driver sleepness. So the study aims to lessen the reported traffic accidents due to driver drowsiness and to avoid a higher risk of accident on the road. That's why we came up with this kind of study wherein we going to to look for the behavior of the eyes using uh, artificial intelligence. So with this one, we are using a methodology wherein there are different stages. So the first stage is a data preparation, data annotation, training, testing, and also evaluation. Wherein this one will help us or guide us in order to finish our study. So on the data preparation, so the creation of the system that with the data set collection, so data image shown here will be used in creating an object detection system. So the dataset are gathered from the Google image and a dataset repository called the Kaggle. So this will be trained and validated using YOLO version 3. So pre-trained algorithm. So these studies may employed 1,000 images in total, with 80% of them being used for training and then 20% of them is on the validation. So the other one, we have the data annotation where we're using a labeling tool for for this. So the study used the labeling tool in Pascal DOC format. So we have bounding boxes are created in the image, as you can see the green uh, image here. Focusing on the target object of to be detected, and then saving the annotated image will be generate a text file that contains the x and y coordinate of the annotated image. And then with that, we are going to have also an object detection framework where in terms of accuracy, we're using a YOLO version 3, which is already outperformed the YOLO version 2. Then SFP and RetinaNet are both accurate on version YOLO version 3. So and also much faster than the previous version. So this is how the process will work, or how from input to output really. And then with that, we have also by doing those training. So we come up with the training and evaluation. Where in the area under the interpreted CR curve, which may be computed using the formula here. the first one, this one, and then the second one. So the defined as average precision 80 in the interpolated accuracy to interpret a certain level of recall. R is defined as the highest accuracy identified in the stage of uh, recall. So mean average precision and then this one, mean average precision formula. So across all measures denoted as mean and average precision. So generate model as are evaluated using their mean average precision. So for testing, the research will utilize the model with the highest mean accuracy precision for detection model like RCNN and YOLO. So the higher the model and AT, the more its accuracy is detection. So on the result and the discussion, so a training validation, so a graphically represented the training in validation of the trained data set. So the training and validation error are represent on the y axis, while the number of efforts on the represented of the x axis. Now on the model of evaluation, the average precision metric metric is frequently used to evaluate the accuracy and object recognition algorithm and models such as RCNN and YOLO version 3. So for the visual representation of the epoch concerning the value of NAT and the evolution training of the data set. So as you can see here that we have a great uh, NAT or the mean accuracy or average precision. So with that, the evaluation of the model here, as you can see, we tested a video. We also put a video on the system in order to detect based on the bounding box. So the detection accuracy result per frame of the video testing. Uh, so in the figure, and then the short clip video as shown in the graph where there are 50 frame where 50 frames where variation and fluctuation of detection accuracy is graphically represented. So the detection accuracy per frame range from 40% to 89%. And in totally, the model has a 100% testing accuracy. So video image frame. So we have frame A, B, C, and D. So we're in it has a value of 4.2%, 5.9, 42.8, and then the other one is 59.2, 67.1, and 87.79 respectively. So the detection accuracy from 40 to 89 can be improved by adding more uh, data sets. So this is the graph shows from 40 up to 80%. Now on the conclusion that we come up based on the result that we have. So the research indicates that deep learning is used to diagnose eye drowsiness, which can help deter road crashes due to driver fatigue. And then with that one, we have also a recommendation of future work if if they want to continue with this one. So suggest that the eye detection for driver enhance the system such as adding another data set that can detect the driver and attentiveness using image that cause the driver distraction such as texting while driving, eating or drinking while driving, and so on. And then also if they're going to integrate anything that can distract the driver from sleep. So with that, thank you for the opportunity in presenting our research. So we would like to thank you, the Batangas State University, for letting us use the facilities in training our research. And these are the reference. the serious in our steps. Thank you. Thank you everyone and stay safe.